site that is written. It's click on level 1, go through it, start reading it.
It's right there. This is just the default.
Yeah, great day now.
Thank you. You too.
Well, no, I just remember French side series.
Most of them are elementary.
Most elementary? Okay. Well, so University Fresno, and then I got my PhD. Look at the walls on the way up. We have craters on there. Basically, I was growing testing. It represents probably the best gray water or laundry water that you drink. So the mass balances are they change around on an IV bag with a membrane in it. I buy those as experiments on the internet for $50, and I put fresh water in there. Does anybody know how much pressure the water is going to be pulled into the sea? Approximately half a megawatt. In the 60 gas exchange membrane on this side, the pressure of water is different when it's above salt water, as probably have 4 of these, and
These are fascinating and amazing machines.
about 20 times as much liquid in a day. So on the grow algae, and then it uses the same.
That classroom model or the simplified version that we can take back to the classroom?
Well, that's actually why I showed you this thing. And it's called the X-bag process. So this is actually a good bench scale chemical process. This is simply activated to show the activity of the. What we have here is a piece of hardware that operates at room temperature by drawing a vacuum in a leg. So our problem with this particular system is it's a bit of a power hog. It takes that because it's still slightly liquid. So you get about 9. So yes, you're going to add back in some type of carbohydrate. Normal water with normal pH. So all water is going to have a certain carbonate component in waters, and all water that tastes good instead of tastes like. Okay, because everywhere in the real world you balance within the water. So all natural water. In cases where you have waste heat, like if you have a power plant next to the ocean, it can be a highly efficient way to do water, which in essence is also an environmental impact. So is the reject of salt back into the ocean. You use about 4 or 5 different. Then we've got
Well, why don't you guys go in alphabet?
You know how much stuff you could shove into an object?
I would say simply take everything out of your bucket. Dirt and water.
Dirt and water. Sounds like mud to me.
Making mud pie.
And the great wizard Candinium.
There you go.
Candia.
Does it feel any different when you start?
But we're supposed to watch first.
Really neat. Do it again. Do it again.
Yeah, it's kind of frozen. All right, guys.
So you're lifting it out of the bag.
All right, so just mush what's in the bag together.
Comet.
Here, let's put it back in.
That's dry ice in your right hand, right? Is there stuff inside of there? It's like frozen. It's got like. I don't want to be cracky. What do you have there? Of your comet. Oh, and right there we can see it all steaming.
Oh, melting.
Yeah.
What about the sign?
Well, there's the Zeppelin flying over. Really? Was that earlier? Okay, let's see if I can. Why don't you tell us?
I'm not trying it.
Oh, yeah, I can.
There's too much.
We're still kind of in the mimeograph mode, you know, where this is said NASA core, the core, and so this is the catalog, and there's little catalogs that you're going to not be able to use. So, but you should take a look at some of those, and we have them on different topics. It's mostly make like a runway, and then it'll actually glide.
That you can become involved in. The program model is at 1 or 2 schools, and all the reasons still be considered in the school, even though it's an elementary setting. We have something happening in your school, might be something in the classroom.
lost that website. That was about the answer.
That's okay.
What you do is bring in a blank one, then we